Hello folks, how's it going? This is Mike coming back at you here with another video on discrete mathematics. In the previous video, we looked at some examples using truth tables to work with the biconditional operator and seeing how some things were logically equivalent to each other. In this video, we're going to begin to take a look at arguments and figuring out whether arguments are valid or invalid. What do these things mean? How do we find them out? And then a couple key phrases that are related to arguments. So unlike the meaning we know of and use in our everyday talk, in logic, an argument is a sequence of statements, and an argument form is a sequence of statement forms, that is to say expressions with P's, Q's, R's, and logical connectives. Negations, conjunctions, disjunctions, conditionals, biconditionals, all those kinds of things. Now, I'm going to use these terms pretty much interchangeably. If I talk about an argument, I'm talking about an argument form, and vice versa. All statements or statement forms in an argument are called the hypotheses. And when I say all of them, I mean all of them except for the last one. The final statement or statement form that's in an argument is called the conclusion. And there's a special symbol that we write immediately before the final statement form, and it's three dots in the form of a triangle. It means therefore, and this is what we use to show that this is the conclusion of the argument that we are trying to show. Now, arguments or argument forms are either valid or invalid. So what does it mean for an argument to be valid, or how do we know when an argument is valid? If all of your premises being true implies that the conclusion is true, then the argument or argument form is considered to be valid. If this is not the case, if when all of your premises are true, then implies that the conclusion is false, then the argument or argument form is not valid. And the way that we truly determine whether or not an argument is valid is through the use of truth tables. Now, very shortly, we're going to see a couple examples of what we mean by an argument or an argument form. And in the next video, we're going to see these two samples, and we're going to show whether or not these arguments are valid. But we list the sequence of steps that you have to do in this video to show the validity or invalidity of an argument by using truth tables. So you'll be given your argument/argument form. It'll have some hypotheses. It will have a conclusion, and you have to create a truth table to determine whether or not the given argument is valid. What you're going to do is you are going to essentially fill in the entire truth table. You're going to come up with the truth values for all statements, all statement forms, all premises or hypotheses that are in your argument, and all the truth values for the conclusion of your argument that you had to find. So step one is basically fill in your whole truth table. Now we're only going to look at certain rows in that truth table, and this takes us right into step two. You're going to only focus on the rows of the table where all the premises are true simultaneously. These rows are called the critical rows, and I'll mention this in the next video, but circle these rows, put an arrow next to these rows just highlight them so that you know that these are the rows that you have to focus on. Now, what you do to determine whether or not your argument is valid, look in each of these critical rows. If in every critical row your conclusion is true, then the argument is valid. I'll say that once again, just to be clear. If in every one of these critical rows, which are the rows where all the premises are true at the same time, if in every critical row your conclusion is true, then the argument is valid. If there's even one row in which all of your premises or hypotheses are true and your conclusion is false, then the argument or argument form is considered to be invalid. Now, as I said, we're going to really see this in our next video. We're going to go through a few samples to see how we actually use this three-step process, but this is just me stating it right now. So here are just a couple samples of some arguments or some argument forms. Looking at this guy here, we see that we have two lines of statement forms. Then we have our three dots here, and then we have one more statement form here. All of the statement forms listed prior to those three dots, each of those are hypotheses, and then what's written right after the three dots is a conclusion, or is the conclusion of the argument or argument form. So we have P or, Q or R as a hypothesis, and then we also have not R as a hypothesis. And then our conclusion is P or Q. Similarly, this guy here, P implies Q is a hypothesis. Q implies P is a hypothesis. We have our three dots, which stands for therefore, which tells us that this thing here is going to be our conclusion. Now notice that in each of these two arguments, there are two hypotheses or two premises and a conclusion. There's a particular name for this kind of argument or argument form, and there's a special name for it because it's so common. The name for this type of argument form is called a syllogism. And there are two syllogistic forms that are most commonly seen. These are very, very basic. They're called Modus Ponens and Modus Tollens. Modus Ponens is the following argument. Your hypotheses are P implies Q, and your second hypothesis is P, therefore Q. Modus Tollens, first hypothesis is P implies Q, second hypothesis is not Q, therefore not P. These are two examples of valid arguments or valid argument forms. But just looking at these should be ringing some bells. The entire thing, the entirety of modus ponens, if P then Q, P therefore Q. For this, you should think back to the truth table for the conditional. We knew that in a conditional, if P was true and the entire conditional was true, then the only way that those two things hold is that Q has to be true as well. So for that, think of just the truth table for the conditional operator. Modus tollens, you have P implies Q, you have not Q, therefore not P. having the conditional and then seeing not Q, therefore not P. For that, this looks like the contrapositive. So Modus Tollens is basically just looking at the contrapositive. So we will get into some more basic valid argument forms a little bit later on in the course, specifically in the video after next. But as I said in the next video, we are going to be going through several sample problems to see whether or not arguments are valid or not. If you have any questions or comments, be sure to drop them in the comment section below. Otherwise, until the next video, take it easy, guys.